Hi everyone, Kevin Klein speaking. It's a couple minutes from the top of the hour and we will kick off at that time. One of the most common questions we get whenever we present a webinar is, will I be able to get the slides, the scripts, and a video of the webinar afterwards? Or similarly, we get the question, will I be able to get access to all of that good stuff if I wasn't able to make it to the presentation? And the good news is, yes, all of this will be available for you to download afterwards, and we will actually automatically send you an email. So you don't have to reach out to us or remind us. We'll actually get that out to you, and usually within no more than 1 or 2 business days. Since this isn't a Friday, we'll probably get it out to you no later than tomorrow, say lunchtime. But we'll have all of that ready for you in short order. One other quick note before we begin is that if you are interested in asking a question, what we're going to do is ask you to use the Q&A feature of GoToMeeting. And you know, that's available on the kind of pop-up control window that is in the user interface to GoToMeeting. So be sure to use that interface. There's another one that might be a little bit deceptive called Chat. And I won't be keeping as close an eye on the chat interface, but I'll keep that open too, and hopefully I'll be able to see both, but I can't guarantee that I'll get to both the chat and the question interface there. All right, so with that, it's about time to begin. We have just 2 more minutes, so we'll hold on until the top of the hour, and we'll kick off at that point. Again, feel free to use that questions interface if you have something in particular that you were really curious about, or if you have questions as we go along. One other quick thought, too, is that we will be doing demos, and we actually, Charles and I were just chatting about this before we began the broadcast, and that is we've got a lot of content in here, quite a bit more than we'll probably be able to get to in the amount of time. So don't worry about that. You're actually going to get the full slide deck. So if we didn't have time to cover every slide or go through every demo, that's one of the things you'll really want to take advantage of afterwards. So download those resources and read through them and take a look at all of that good stuff in there, because it's going to be very, very useful for you to have all of that. Okay, I have right at the top of the hour, and it looks like I need to close Skype. Let me go ahead and take a moment and do that. My apologies. You're always supposed to close all of that stuff ahead of time, but sometimes I forget. Okay, so welcome to the webinar, 10 Surprising Performance Killers on Microsoft SQL Server. And we could either call this Viscosity Edition or VM Edition, because we're talking a lot about virtualization. And let's jump right in. The first thing I want to do is introduce my co-presenter, Charles Kim. Charles is a real celebrity and very, very well known in the Oracle world, but he also does quite a lot of work with SQL Server. Charles, why don't you tell us a little bit about yourself?
All right, thanks, Kevin. Hi, everybody. My name is Charles Kim. I've been doing Oracle for the past 26 years or so, but a lot of folks don't realize that I've also been doing and playing in the SQL Server space since 1999. And back in the earlier days of SQL Server 2000 and whatnot, I got certified in SQL Server and have been doing SQL Server on and off since then. And from a virtualization perspective, we've been virtualizing Oracle and SQL Server for the past 10 years, and not just any kind of SQL Server workloads, but even the heaviest workloads of them all, the monster VMs. And so we have quite a bit of expertise in that area. And And obviously, as you can see, we have numerous books. And one of the areas that I focus a lot on is on Linux. And so I'm really looking forward towards doing lots of presentations on running massive scale SQL servers on the Linux platform in a virtualized infrastructure. And so if you go to the next slide, Kevin.
All right, here we go.
A little about viscosity. One of the key areas that we specialize is in data replication, and we leverage SharePlex as our platform. That's SharePlex by Quest, and we have been doing data replication since the late 90s and have been doing lots of presentations and numerous zero downtime database upgrades and migrations between SQL Server and Oracle and MySQL and even Postgres. And so at the same time, you can see that we actually have services around SQL Server administration and SQL Server managed services. And we leverage SQL Sentry quite a bit as part of our managed services delivery process. And so we're proud to be doing this joint presentation with SentryOne. And as you can see in the bottom, there's a lot of database focus that we have. And one of the key areas that we work on is on VMware virtualization. So I'll turn it back over to Kevin.
Thank you, Charles. Yeah, that's a big business these days. There's just so much virtualization happening with database workloads. So for those of you who don't know me, I've been in the SQL Server space for a long time. I was actually an Oracle person for 6 years, from the mid-'80s through the mid-'90s, very heavily on Oracle. But around 95, I started working very heavily with SQL Server as well as Oracle, and had some experience with IOUG, where, Charles, you're very active today. And I was leading a very large database team and doing Microsoft SQL Server work, and was tapped by Microsoft and an independent body actually to form the Professional Association of SQL Server. So I was one of the first 9 founding members, and I was also a president for several years back in the day. It's now a huge big party. So if you are a SQL Server person and you haven't already heard of it, the past summit, which is the big annual conference, is coming up at the end of the month. About 5,000 or 6,000 people will be there at the event. So I really encourage you to take a look at fantastic training. I'll be there. I've got several sessions at the event. There's 160 other sessions, as well as pre-conference seminars, full day and half day deep dive training. So do get involved in that. Also, I've written many books. I'm author or co-author on 11 books. My best known book is SQL in a Nutshell. So I'm actually working on a 4th edition of that one to update it for all the newest ANSI SQL standards, as well as for Oracle, MySQL, SQL Server, and Postgres. And I'm also really active on all these other social media platforms, so I hope you'll connect with me. In fact, I have a special plea. My birthday is at the end of the month, and I am about 70 or 80 followers away from hitting 10,000 on Twitter. So if you're active on Twitter and you are not following me, please do at KE Klein. I would appreciate it. I would thank you, and my children would thank you. So hope you'll do that.
I'll make sure to help you with that, Kevin.
All right. Thank you, Charles. Now, Charles had mentioned SentryOne just briefly, and that he uses it. And we actually have, a large customer base. And there's 2 reasons why we are so appealing in this market. One is that we have the broadest platform. We cover more of the SQL Server data platform than anyone else. So we cover not just SQL Server, the relational engine. We go all the way down into Windows. We have very deep monitoring of the virtualization middle tier. So if you have Hyper-V or VMware, we cover both of those. We go into SQL Server's analytic services. It's business intelligence product called SQL Server Analysis Services, and then all of the cloud offerings that they have, as well as APS, which is the the very highly scalable, kind of high-end turnkey system. And if you want to see any of these, I would be honored to help you with a demo, give you a free trial of any of the software. You can set that up yourself at centuryone.com, book a demo. Now, if you're not looking for product, we do also do a lot of things that are free. And I think our most popular offering are these ebooks here. And we have 5 ebooks, and they're not little 40-page chapter-sized ebooks. You can get them all in the Amazon Kindle bookstore for $10 each, but they're real books. They're big, and the articles in there are written by some of the top experts in our industry, people like Aaron Bertrand, Paul Randall and Kimberly Tripp, Jonathan Cahias, myself, and others. And the smallest of those is about 320 pages. So they have hard-hitting information in there. We also have a number of websites where we give back. So you might take a look at SQLperformance.com, where we have lots of really deep dive articles on improving SQL Server performance, whether that's through better coding practices or maybe server settings and configuration options. Answers.SQLperformance is a really neat website in which you can actually ask questions, and we will give you free performance tuning advice on queries. So if you have a query that's particularly hard for you to tune, upload the execution plan there, and we will give you a hand with that. SQLcentury.tv is where all of our videos go, so this video will be posted there eventually. Our team blogs are at blogs.centuryone.com. And then finally, the last thing I want to mention is our very popular product called Plan Explorer. You can see I've got my mouse hovering right over it here. Go to centuryone.com/Plan Explorer. It is a query tuning tool for SQL Server that is probably the most popular free tool in the SQL Server world. It's kind of like Toad is for Oracle. You know, it's a must-have that everyone who does serious SQL coding on SQL Server uses. And it is so free we don't even ask for an email address. So you literally have no risk at all. Don't be afraid to download it and start using it right away. Okay, so let's move on. One of the things that a lot of people think about when we're talking about surprising problems with SQL servers, a lot of times they'll try to fix their performance problems by throwing hardware at the problem. You know, I'll hear people say, well, we don't have a very fast hard disk-based storage system, so maybe we'll upgrade to SSD. Or they say, you know, I still got a few slots open for memory, so I'll throw more memory in there. And while many times those kind of solutions are helpful, the actual research tells us that hardware is often not the problem. It's only really a problem about 5% of the time. And this is research done by Gartner, by the way, if you're the kind of person who likes to know where your numbers are coming from. Settings, configuration options, Windows options, as well as the SQL Server options, that's about 15% of the problems. But about 80% of our problems are actually coming from the code that we write and run against SQL Server. I always joke that, you know, sucktacular SQL, you know, if it sucks really bad, it's going to suck up all the resources. You know, if you have people writing select star from a table without a where clause, and it's a really big table, and you have that happen a lot, that's going to chew up all of your I/O. It's going to chew up all of your memory and so forth. So a lot of what we're going to talk about today is code-based recommendations. But we will talk about hardware, we'll talk about settings, and Charles is going to give us a lot of great, really, really good information about virtualization, which is really an interesting problem because a lot of us don't even realize that we are running on virtualized machine. So that's another aspect of the whole performance kind of puzzle. So we're going to talk a little bit about the hardware stuff, CPU, memory, file system. We'll talk about database design, you know, things like the data types you've chosen. And we'll talk about coding, Transact SQL coding. Now, if you're an experienced coder, you know that there are hundreds, maybe thousands of best practices for how you write your SQL code. So clearly we're not going to get into everything. It's not going to be comprehensive, if you will. But we will give you a couple quick surprising things that you may not have known about ahead of time, even for an experienced person. All right. So one of the ways I like to frame the discussion is I've had a customer that was a major world-renowned financial institution out of London. They had a very busy system, 10,000 transactions a second. And that's not the IOPS, that's SQL transactions. So the IOPS was actually quite a bit higher than that even. And they also use SQL servers built in always-on availability groups for high availability. So they had a lot of work happening all the time. And when we looked at Task Manager, this is what it looked like. Have you ever seen a Task Manager that was actually that big, that had that many CPUs? Now, Charles, you mentioned you've worked on some really high-end applications, and I've worked on thousands myself over the years, but I've only seen something this big once or twice before.
Yeah, I've only seen things like that in Wall Street customers.
Yeah, exactly. And when you look at this, you can see that there's a real common pattern in all of them. There's a high plateau of CPU on quite a few, and some of them are all the way pegged out. Some of them, they pick up after a moment or two, and then they peg. When we have time, maybe we'll talk about these really high-end edge cases and how they're distinctive from our more traditional workloads. But one of the just surprising things about SQL Server is that it's not a SQL Server thing, it's a Windows thing, and that is the Windows default setting for CPU is really, really dumb. So let me actually flip over here just to my desktop and show you what is happening. What happens is the default is balanced power setting, not high performance. And so if you're running on Intel processors, and this is true on all versions of Windows, up until the latest releases even, by default, it's going to give you only 78% of the CPU processing speed. And that's just ridiculous because SQL Server is not the kind of, going to be running on the kind of server that you pick up, put in your bag, take on an airplane, fly across the country, and open up again. It's plugged into the, to a power backup supply system, and so you've got a situation where you always want to be at peak performance, not at this kind of partial performance. So where this comes from is if we, and again, I'm just going to pop out to the OS here, in the lower right corner where you have your battery, and then you right-click on it and it says Power Options down here. You pull that up and it'll say Balanced, High Performance, and Power Saver. Well, high performance is not the default, and I've had many people tell me, "Oh, this is not a problem for us. We hired Dell, who, our server vendor, or we hired HP, our server vendor, to come in and set up our SQL server. So I'm sure this is fine." And then they go back and check, and sure enough, it's unbalanced. So please make sure that is turned off and disabled. You don't want that to be the kind of thing that catches you by surprise. All right, let me make sure that Skype stops popping up on me. So yeah, surprising but true. Okay. Now, I mentioned that licensing can be an issue. It is surprising to a lot of people as well that AMD CPUs have a different pricing scheme than Intel CPUs. And also, we also see a lot of people who buy the biggest, latest, greatest CPUs they can get. And many of the CPUs nowadays are not getting faster. They're gaining more cores. More cores won't help you if your application is single-threaded. And I do see that quite a lot. And so you buy a silicon wafer that has 32 CPUs on it, and it doesn't get much faster. That's because everything is being done through those single cores, or a single core at a time.
Yeah, I talk about that too, Kevin, as well, in my section as well, is that it's not all about having more cores. It's all about having and doing more with less. And it's always better to get CPU cores that are faster than to get more cores in the box.
Great point.
And obviously it impacts licensing too.
And along those lines too, and I know you speak about this a little bit, but it's really important that you know what the workload is. I mean, so when I'm talking to these DBAs and they're like, oh, I didn't realize that I had a single-threaded workload. That's on you to know those kind of things. And, you know, to see that one CPU is really getting pegged out, and, you know, something along those lines. That should not be a surprise to you. So that's a mistake, you know. And it's a, you know, it's an honest mistake, but it's something that you can control and make sure that you're not going to have a problem with. Robin, by the way, in the Q&A has asked if I can go back to the previous slide, and I hate to tell you this, we've got to get through a bunch of slides in a limited amount of time. So if you want to drill in on that, please take a look at the slide when you can download it. Memory is another interesting area inside of SQL Server that can hurt you. I'm sorry, I shouldn't say that it can hurt you, but if you just go with the defaults, it can hurt you. And what happens here is if you've ever set up and installed a SQL Server, you know that there's really only two memory settings inside a SQL Server. Simply the minimum and the maximum memory that the instance of SQL Server gets. That's a lot different than Oracle. Oracle, you can tune every cache within your memory allocation. SQL Server doesn't give that to you. So you can just say min and max, and the default is the theoretical max for Windows the last time they calculated that, which was about 2 terabytes of RAM. The reason that this is a problem is that SQL Server doesn't really believe you when you say you have 2 terabytes of RAM. So what it does is every time that it adjusts its memory and the cache and so forth, what it does is it actually calculates. It does a CRC check to see how much memory is really in there. So you need to take a moment and make sure that if you have a SQL Server that, let's say it has 16 gigabytes of RAM, and this includes inside of a virtual machine, you need to make sure that you tell SQL Server that it can't have 2 terabytes of RAM. You know, you probably, and if you need some help with this, I do have some formulas for you to how to properly calculate how much RAM SQL Server can have for its max memory allocation. But what you want to do is just a quick rule of thumb would be to set aside between 2 and 4 gigabytes of RAM for Windows. And that's assuming that SQL Server is the only major application running on that instance. And so if you had a 16 gig server, whether that's virtual or physical, you tell SQL Server you can have 14 gigabytes of that. If you didn't do that, SQL Server would, go back to the previous slide, SQL Server would say, oh, you know what? I don't think you have 2 terabytes of RAM every time it adjusted memory, which it does hundreds, maybe thousands of times a second as the workload is being processed. Oh, and I do have a typo here. Thank you for pointing that out, Michael. That should be min, not mix. My bad. Yeah, and so it has to spend a couple cycles doing a CRC check and checks to see how much memory really exists, and you literally waste cycles every time SQL Server is doing any significant work. And so this is one where you need to go. It won't fail, won't give you any error messages or anything like that, but it will give you some missed opportunities, right? It's going to take a little bit of overhead. I don't have time to dive into lock pages in memory, but I'll tell you this. If you've heard of lock pages in memory, the answer to every technology question really is it depends, right? And so you will see bloggers who tell you you should absolutely use lock pages in memory, this Windows setting. You'll see other bloggers and, published authors and wise people of the SQL Server world who say don't use it. And I'm a little bit more pragmatic about that. I say it depends. It depends on how well you know the workload. It depends on how many applications besides SQL Server running on the instance. So there's more. It's a more nuanced question than what a lot of the blogs out there seem to say. Again, if you want more information on that, drop me a note. I'll be happy to help you with that. Okay. A few other things. A lot of people misunderstand what those settings mean, max server and minimum server. They think that, oh, I've told SQL Server you've got 16 gigabytes. So they think that SQL Server will acquire all 16 gigabytes while it's starting up. And that's not the case. It actually only acquires what users are asking for. So it could be that you restarted the SQL Server on a Saturday. No one asked for anything until Monday morning when they started coming into work. And so it's, SQL Server sits there with maybe a gigabyte of allocated RAM actually in use. And then it finally grows until it consumes a lot of that space. I mentioned in passing leaving some space for Windows, if you don't know anything else. Let's say you're running analysis services, or as Larry is asking in the Q&A here, you're running SSIS on the same SQL Server. The process by which you figure out how you should actually set that max memory setting to get a really good accurate number requires a little bit of monitoring. And so there's some perfmon counters you can pull that will tell you exactly what the right number is. And again, let's take the discussion offline and I'll give you those formula. But typically what I do, if I don't have time or I don't have access or permissions, I usually recommend that you set aside 2 gigabytes per additional application that you want to run in addition to SQL Server. So say you've got a 32 gig SQL Server that also runs analysis services, reporting services, and SSIS. Well, if you include the Windows OS, that's 4 other things running besides SQL Server. So that would mean reserve 8 gigabytes for those and set your SQL Server memory to 24 gigabytes. Okay? And I'm going to speak about this in just a little bit more detail, but particularly up through about SQL Server 2012, there were some problems with how these memory settings applied. And here's what it looks like. And this is another area actually where the version of SQL Server you're running on can make a big difference in your performance. So if you're on SQL Server 2008 and earlier, these versions of SQL Server were much more subject to internal memory pressure problems. And so you can see here that the buffer pool in which you set your max memory setting, if I said 24 gigabytes for that server that had all of these different SQL Server, other SQL Server applications running, analysis services, integration services, it also didn't count in that setting the CLR stuff, multi-page allocations, the direct Windows allocations, the thread stacks. So SQL Server might actually be using a lot more memory than that, and it was much more rigid, is much more rigid in terms of allowing memory to flexibly move between the data cache and the plan cache and all the little caches like sort cache and hash buckets, and log buffer and things like that. So those are some problems out there. On the newer releases, 2012 and later, the entire allocation, anything that might be used by SQL Server now, fortunately, gets counted as part of the max server memory. So it is also much better. I have kind of wavy lines here at allowing a little bit of float between the data cache and the plan cache. So this is another reason you want to set that max memory setting in SQL Server, because if it doesn't know what it actually has, and it has to go back and do that CRC check, anytime you have internal memory pressure between things like the data cache and the plan cache, and it has to give one of those caches a little more memory for a short period of time, then SQL Server will slow down because it doesn't know how much it's got, and you'll have to go back and calculate that, and spend several cycles making that happen, and then come back and do the buffer allocation changes. And so that's another reason that you want to do it that way. Before I move off of the memory topic, Bruce asks, would you want to set up, if you had multiple instances, would you want to set up 2 gigabytes for each instance? No, I wouldn't necessarily want to do that. Again, it depends. It depends on how busy they are. Some of those instances might be much heavier utilized, one compared to the other. So really what I would want to do is check my perf bond counters and my weight statistics, which I'll show you a little bit about in a minute, and make sure that I'm not doing that for a server that's most heavily utilized. Wouldn't necessarily want to balance them each having 2 gigabytes. I might want to give one 8 gigabytes and then 2 or 3 others 2 gigabytes. So it's one of those things where I'd want to measure first, measure twice, as they say, and then cut once, rather than just take a swing at it and hope it works. All right, again, we've got to move on. We got a ton more slides to talk about. Now, one of the things that SQL Server has since SQL Server 2005 is this really fantastic feature that existed in Oracle for a long time called weight statistics. And if you spend a lot of time tuning SQL servers, like I do, you'll see that memory pressure does show up in the weight statistics. You'll see network sometimes. You'll see CPU pressure. But more often than not, again, this is another customer scenario, more often than not, you're going to see weight statistics specifically related to I/O. That seems to be the really big issue there for so many of our environments. I/O is the slowdown. So let's talk about a few surprising things about I/O behavior on SQL Server. Okay. Let me switch back to my normal pen. So one thing is that this is something that has been fixed in the latest release of SQL Server, specifically for TempDB. But this is something I've been recommending for decades on not only TempDB, but also on your really busy user databases. And what happens in a database, a SQL Server database, is that we have inside of SQL Server these different structures that help you get around very quickly inside of the database. So for instance, if you're going to create new objects and write records into those objects, we have these kind of mapping structures called page free space pages. Those appear every 64 megabytes or so inside the data file. We also have SGAMs, which is the System Global Allocation Map that tells where all the tables are and indexes. Those appear every 4 gigabytes or so. We have IAMs for index allocations and GAMs for Global Allocation Map. Now, every time a user has to do work and instantiate data or retrieve data, SQL Server takes just a brief moment on that user's behalf and issues something called a latch, which is a very kind of lightweight memory, allocation of memory, a hold on memory. And it grabs one of these PFS pages or index allocation pages, mapping pages, so that it can find its way around to the data that you want, either to write it or to read that data back. And those are very, very fast. They're in memory, so they might be, completed in nanoseconds. But what we find happen a lot of times is because of having just one database file, and we have an application that has 200 users active at one time, or 300 or 3,000 users at one time, what you've got here is a situation where each of these latches really start to add up, and so we get latch contention on these structures. And so what you're better off doing in a situation like this is to create more than one database file for not just TempDB, always TempDB, I should say, and your really busy user databases. So, yes, this is a big problem. Now, in SQL Server 2016 or 2017, one of the really recent releases, they have done this by default for SQL Server, so that it will automatically create for TempDB 4 data files, and they're also set up automatically so that they grow at exactly the same time and in the same way. You can do that yourself if you're running on earlier versions of SQL Server, and you should do that yourself. The right way to do that will enable you to take advantage of SQL Server's round-robin proportional fill algorithm. Okay, so this is how SQL Server writes to the disk subsystem. What it does is if you have just one file, as you're going along, you're writing data into the one database file, right? And it's writing and writing and writing, and it's getting closer to being full, and then you take a look at it and you're like, oh, this is getting pretty full, so I better add another database file to it. So you create a second 4 GB database file. So now I have two that are the same size, and if you're like me, you want your databases to be predictable and stable. But you may not realize that SQL Server is doing its writes round robin. So that means it goes from one data file to the next. But it does it according to the proportional fullness of each of the data files. So data file 1 is 80% full. Data file 2 is empty. So that means 80% of the writes are actually going to come here to data file 2 and not to data file 1. Now, again, both of them are filling up. So I add another file. And again, what I have here is 80% of the writes go to data file 3, and 10% go to data file 2, and 5% go to data file 3, and on it goes. What you want to do with your database files is you want to create them all at the same time so that they don't have to auto-grow frequently. You also, I don't have this written on the slide, but you also want to enable a trace flag 1118 so that whenever these files grow, they grow all of them together and at the same time. And what happens here is when they all are about as proportionately full as the one next to them, SQL Server is able to go from file 1 to file 2 to file 3 to file 4, back to file 1 to 2 to 3 to 4 in a round robin fashion and balance the I/O load so that you get much better performance that way, and it's much more even. Now, there are exceptions to the rules. Sometimes you might want, I don't know, a particular data file to be on SSD or something like that. But I think most of us want the database read and write behaviors to be very consistent. And so you won't get that if you just throw additional files out there that are maybe of very different sizes, that maybe auto-grow in very different ways, or simply are on different parts of the file subsystem. And so, so it's the kind of thing that you may be doing this to yourself. Now, note again, what I'm talking about here is for versions before SQL Server 2016. 2016 does this by default now for TempDB, but you do want to add this in for your user databases and for any version of SQL Server you're running before 2016. Okay? All right. There are similar problems. Well, there are different related problems on the transaction log. The first thing is you only ever want one transaction log file. But the other thing is you want that transaction log file to be fully allocated when you create that database. You don't want it to auto-grow over and over and over again. Every time it auto-grows, SQL Server creates something called a VLF, a virtual log file, and it has a small 8K header between the previous log file and the next log file. And so, the longer anyone waits on the transaction log, the longer it takes for any work to get done, because it has to be written to the transaction log before it can go forward. And so every time SQL Server auto grows, everybody has to wait for it to finish. So you don't want that to happen on a really busy server. That's mildly annoying. But what's really a problem is if you ever have to recover that database. If you have to recover a database that has many hundreds or thousands of log files, of virtual log files, VLS. Currently, the biggest I've ever seen personally, I was looking at one customer's SQL Server, a big database. It had 54,000 virtual log files. That means that it had auto-grown, or maybe the DBAs had manually grown it themselves, but it had been grown 54,000 times. And that, for that 1.5 or 2 terabyte database, that literally added about 2 hours to the amount of time it took to recover that database. So if they had instead created one transaction log file that was very, very big to begin with, let's say 500 gigabytes at the beginning, you would have only one VLF. And so the end users would never have to wait for the transaction log to grow. But more importantly, you as a DBA, if you are a DBA, you never have to sweat how long it's going to take you to recover this database, because there's no time more unpleasant than when your manager walks into the cube, you know, and is angry. It's like, how long before this database is back up? You don't want that. All right, let's move along. I think I only have an hour's worth of data here, and Charles wants to talk a little bit too. So let me skip a few of these things. Here's some notes on how to fix some storage problems. If you've got disks, for example, you've got SSDs, that's even better. There's some things you can do in your design, like your clustered indexes, that can make your indexes a lot tighter. Another thing I want to remind people of is that SANs, for most of their lifetimes, really were not about performance. They were about aggregating storage purchases. And so part of the marketing that the SAN companies put out is that SANs are, you know, they're a panacea, they're a cure-all to all of your problems. When the actual fact is that they're, at least in my experience, they were often just the central location of all my problems. You know, and when you think about it, we have to you know, query data from the back end, pull it up through the RAID controllers, up in a memory, across the network. You know, we make the request, it goes to the HBA, and then down to the you know, the server memory, and then it finally comes back to you. So it's a long, drawn-out process. And sometimes even the network alone can slow you down when you have SANs there. Charles, do you want to jump in on that?
Yeah, in fact, VMware states that 80% of all performance problems that you encounter is storage related. And and there's numerous things that we can do to alleviate and mitigate a lot of these potential performance issues. And as Kevin talked about SANs, right? You know, one of the key things that we have to look out for in performance is latency. And there's three big areas that everybody tries to look out for: latency, IOPS, and throughput. And it's in that order. Latency is the most important thing. And as we evolve in our storage technology with all flash arrays and solid state drives, right? We can actually expect latency to be less than 5 milliseconds. And your traditional, you know, SANs that you have, and even now there are tiered SANs, right? When you have, you know, caching with all flash and SSDs, and you have different tiers of RAID 10 and RAID 5 storage, and you know, with different tiers, right? Even with those technologies, we can actually we should be able to expect like 10 milliseconds of response time, right? And you know, a lot of storage advocates will tell you that you can maybe settle for 25 milliseconds of latency, but in modern SAN architecture, we should be able to expect, you know, less than 10 milliseconds. And if everything is architected properly, right, we can actually get an enormous performance with all these new technology that's coming out.
Yeah, huge performance boost. Exactly. Now, this is kind of a catch-all right here, and what I'm going to do is I'm going to flip over to Management Studio, and I want to show you a quick example of a database design issue, and that is there's something called implicit conversion in SQL Server. And if you've been around for a long time, you know that SQL Server will allow you to create tables and, you know, to do queries against them, and not be really hard on you and about the data types you're using. But this is actually it's one of the biggest causes of terrible performance in queries that I see really often. So say, for example, you've got a table called product category here, and the category ID is an integer in that table. Someone else later on created the product table, or maybe one of your developers created a stored procedure, and in their stored procedure, they declared the category ID as a varchar instead of an integer, okay? Now, if the data types are what Microsoft calls compatible data types, like big int and small int, or varchar 50 and varchar 100, or even char for that matter, it seems like that'd be no problem. And in fact, it is no problem because they're declared compatible. However, there's lots of things that are incompatible, but unless you've been told about it, you don't know that this is the case. So here's one case. Integer and varchar are not directly compatible. Believe it or not, in varchar and varchar, crying out loud, they both have the word varchar in there, but they are not directly compatible. That's because it happens at a binary level. Varchar is standard encoding, so it's 2 bits per element of the string, and in varchar is Unicode, so it's 4 bits per encoding of the string. And so when we have a table like this and you execute a query against it, so here, for example, I've declared an integer data type, right? If I do a select against that, guess what happens? All right, let me actually turn on my execution plan here so you can see it in better detail. One of the really interesting things that happens inside a SQL Server, anytime SQL Server has to use a function call against an index, it can't use the index. So you see right here, we've got clustered index scan happening on the table where, and you can even see it in the predicate there, it says convert implicit. So behind the scenes, it had to apply a conversion function for this query to properly process. And that means for you, you didn't do anything wrong as far as you knew. It worked, right? But in fact, it didn't use an index when it could have. And so SQL Server is full of this. We see it all the time. And I've got some more examples, but unfortunately, we don't have enough time to go into these. So it's one of those things that we see this happen from stored procedure to the database. We see it happen in application back to the database. We even see particular ORMs in Hibernate, for example, is horrible about this. Because we're running short on time, what I want to do is take just a couple minutes and let you know a little bit about what's in the script packs that I have here, the demo scripts. I have some scripts that will check database designs and warn you if there are any specific kinds of problems. So here's a script included in that written by my friend Jonathan Cahias that'll actually look at the at the plan cache and let you know if there are any that are in the cache. It's not harmful, so you could run it in production. It just might be slow. And it will tell you if you've got any things in the cache that have implicit conversions happening. I've got other things, another way here to find them, just a quick query here. This one comes from my buddy Panal Dav. And so this shows us everything where we've got some implicit conversion happening as well, a little bit different format there. So there's lots of stuff in these scripts to give you a hand and help you along the way. There's other checks in here for the code quality. One that you might not know about is it'll tell you about deprecated events. And this answers a question that came up a little bit earlier from, gosh, I believe it was Scott or maybe Jason who had asked, how do I find out the latency? So what you want to do to find out many things about SQL Server's performance is you want to look at this DMV called DMOS performance counters. And if I just execute this, you'll see that there are bazillions of them. And that's the official number here. So there's going to be counts in here for how long it takes certain kinds of SQL Server activity to complete. And this particular one, deprecated features, will tell us how many features are being executed on this instance of SQL Server that are deprecated for the version of SQL Server you're running on. So, for example, here I've got set trace event that's happened 133 times since I restarted this instance of SQL Server, but Microsoft is trying to get us to use a different stored procedure to invoke our tracing. So there's a lot of good stuff in here that you want to take a look at. So these scripts, you'll get an email after this event that will tell you how to get the slides in the scripts and also how to get the video as well. Here's another one that also goes into detail about some of the different perfmon counters that, trace flags that I've mentioned, various database settings, stuff like that. So sorry I don't have time to give you a full demo. Like Charles was saying at the beginning, we've got hours and hours worth of content here. So what I'm going to do is I'm going to go ahead and skip ahead now and let Charles take the floor a little bit, and we're going to talk, in this phase, we're going to talk about SQL Server on VMware. Charles, you with us?
Sorry, I had to unmute myself. Thanks, Kevin. For those who are interested in knowing more about virtualization, or if you have an interest in knowing more about running SQL Server on Linux, please let us know. Kevin and I are trying to get a feel of the industry in terms of what the interest is and what people are doing with SQL Server on Linux. I titled this section to say what to expect when you're expecting to virtualize. And a lot of DBAs may not even be aware that their SQL Server databases are virtualized. Unlike Oracle, we see that SQL Server databases are predominantly virtualized already. In fact, the numbers are significantly higher on the SQL Server side than on the Oracle side. So what I tell SQL Server DBAs and architects is that that we need to be able to talk the vAdmin talk. It's easier for us to escalate our conversation and talk infrastructure than it is for the vAdmins to talk database talk. And so, and by us being able to escalate our conversation, right, we can actually talk to the VMware and the infrastructure folks so that when we are virtualizing, that we have performance in mind as we design our infrastructure. And so typically most shops, when they do virtualization, it's always about consolidation, right? And so performance design should come first always over amount of consolidation, right? And so I talk about here a virtualized first approach. A lot of the mature VMware companies, especially the companies in the East and Wall Street areas, they are extremely mature with virtualization. And what they have is a virtualized first policy where you as the DBA and as the application owner must justify why your database and your application cannot be virtualized. And so, their goal is to have less than 5% bare metal presence in their infrastructure. And so, again, it's one of those things that, from a DBA perspective, it benefits us to know more about the virtualization stack. And as you can also see, right, that the app servers and the web servers, they've been virtualized for the past decade. And it's no longer about virtualizing those platforms. And the database world is now the last frontier to be virtualized. And from a VMware perspective, right, we need to make sure that before we virtualize, right, that just like Kevin mentioned before, right, we need to understand and know our workload. And so it's very important for us to have a baseline of what our SQL Server workload and performance is like, right, before, and then compare that baseline against what the workload is after the database is virtualized. And again, if you have a SQL Server database that is performing bad in the bare metal world, right, it's not going to perform well in a virtualized world. In fact, it may and most likely perform worse, right? It's garbage in, garbage out, right? And so we have to make sure that we know what the candidates are and why we are virtualizing, right? Next slide, please. So also from a virtualization perspective, right? We always talk about overhead of virtualization. Um, the VMware savvy advocates will tell you that there's only 1 to 2% virtualization overhead as you go from bare metal to VMware. Um, I'm a little
Yeah.
bit more conservative, and I generally tell our customers expect to see more of a 3 to 5% overhead as you virtualize on VMware. However, if it is not done correctly, and if they don't follow the best practices, right, you can actually suffer 30 to 50% performance degradation if not done correctly. And that's
Right.
why, and that's why we want to talk about this, right? Is that we want to make sure that we right-size our VMware environment, right? And just like we mentioned earlier, right, allocating too much memory or too many CPUs, right, may not be the right thing. We need to make sure that we do our due diligence and properly size our virtualization infrastructure for a number of CPUs and the amount of cores that we allocate for them and the amount of memory, right? At the same time, a traditional OLTP environment, right, is going to be what, 80% reads and 20% writes, right?
Mm-hmm.
And
Yeah.
and in those situations, throwing more memory can be better, right? Or going to an all-flash or solid-state environment, right, may benefit you significantly in the reads, right? So that's also something to think about. And Microsoft and other third-party environments have numerous tools for you to be able to do your baselining and performance benchmarking. With Microsoft, you can use disk speed, and with disk speed, you can actually go and tell it to go simulate a workload, right? Simulate a random workload with, let's say, 30% writes and 70% reads, right? It'll generate an output for you, and you can graph that out and look at the histogram of where the performance drops when you hit X amount of latency and determine the amount of IOPS you can do, right? And you can actually go compare that to your existing bare metal infrastructure, and before you even lay out the database, right, you can actually go and figure out what your performance is going to look like and set your red flags ahead of time, right? Also, at the same time, from a hardware and BIOS settings, VMware publishes their hardware compatibility list of all this hardware that they've actually done testing with, right? And you can make sure that the hardware that you buy is on that list. That may not be enough to guarantee that you're going to have success in virtualizing, because it's not just about having hardware. It's also about having the right set of drivers and having the current drivers and having your firmware updated and having your BIOS revs updated as well, right? And at the same time, you know, from a BIOS perspective, right, we can go and set NUMA enablement and also set virtualization settings on there as well, right? And again, in the BIOS settings, there's settings for power saving as well. We want to turn all the power savings off. We want the server to have maximum performance, right? We also want to enable turbo boosting if it's there, right? We want to be able to overclock our CPUs so that we can get maximum output from our CPUs. Also, we have settings for hyper-threading enablement, right? And we need to be careful not to think that hyper-threading is the same as cores, right? Even though you might see, you know, number of threads doubled when you look at performance monitoring tools. However, you're only going to get maybe 20 to 25% additional performance from the threads that you're going to enable, right? And lastly, we need to enable NUMA in our BIOS settings as well, right? The non-uniform memory access. We're not going to have time to go discuss the NUMA architecture, but we do need to be careful about knowing what NUMA boundaries are, and as we allocate virtual CPUs, to keep the virtual CPUs within a NUMA boundary or a NUMA socket, and also making sure that we don't address remote access of memory. So, and we're also going to talk about storage real quick. And like we mentioned before, 80% of all the virtualized infrastructure performance problems result from storage issues. And we want to make sure that that we set the right settings so that we can mitigate from those potential issues. All right. Next slide, please. So the age-old question is that, is my SQL Server database too big to be virtualized? Right? If you look at the very right column, right, you can see that with vSphere 6, VMware has made tremendous improvements. For example, I can have 128 virtual CPUs now with vSphere 6. And also look at the memory, right? I can have 4 terabytes of memory on a single VM. And
wow.
The network also has increased, but most importantly, look at the IOPS. IOPS is 1 million IOPS per VM now, right? So now from a monster VM perspective, we're talking about these VMs that have 32 cores or 64 cores, right? We can actually have up to a million IOPS for these VMs, right? So now it's not a matter of can I accommodate that SQL Server workload. Now it's about, let's move that SQL Server workload in a virtualized infrastructure, but do it right so that I have the same level of performance. All right, next screen, please.
All right.
All right, before I go to this one, let me talk real quickly about memory, because I forgot to talk about memory. One of the biggest things in virtualization is that we always want to overcommit. We want to overcommit our CPUs, and we want to overcommit our memory, right? And that's the way that we recognize savings, right? And that's fine to do in a development, QA environment, pre-prod environment, but in production environments, especially for business critical applications, right? We never want to overcommit memory for our production databases, right? We want to guarantee memory and do full memory reservations for all of our critical databases. And at the same time, there's a feature called hot CPU plug, right? And so it's the ability for you to dynamically adjust number of cores on a VM, and that VM will recognize the new settings. Even though it's a great feature and whatnot, there's a negative aspect to this, is that when you enable hot CPU plug, it will actually disable NUMA for that VM, right? SQL Server is very NUMA aware, and that will actually impact performance, okay? And from a storage perspective, right, you can see that we have thick lazy zeroed, thick eager zeroed, and thin provisioning options for storage, right? We talked earlier about auto-growing of database files, right? That's what thin provisioning will do, is that on demand, it will actually grow the VM DK, right? And so we definitely don't want that, especially in our production environment, right? The fundamental difference between lazy zeroed versus eager zeroed is that lazy zeroed will pre-allocate the space, but it won't write zeros to it, right? So so we always want to pick eager zeroed thick provision disks for our virtual disks on VMware, right? So think about this scenario, right? A lot of times your storage admins will give you a thin provision disk, right? And imagine if the vAdmins also give you a thin provision virtual disk, and you, as a SQL Server DBA, set up your database files to auto-grow. And imagine what happens with that triple layer of dynamic growth whenever this massive batch job is going to run, right? And so that alone will cause significant delays in response times and latency and performance issues. So we want to pre-write zeros to our disks up front. This takes a long time, especially if you have, let's say, a terabyte database file, right? And in fact, that could take hours. And so this is where, again, knowing your, being able to talk to the vAdmin and knowing a acronym called VAAI, which stands for vSphere Storage API Array Integration, right? It's basically a fancy way to say it's a hardware offloading API, right? So, so instead of sitting there and waiting for this 1 terabyte to be written with zeros, it will actually offload that to the storage, right? So knowing that kind of talk will, ease your conversation and being able to convince them that this is a worthwhile technology, right? Next slide, please. And I'll end it with this. So with virtualization, right, we will actually increase our queuing across the entire stack. And so we talk about queue depth in the operating system world. We talk about queue depth in the storage storage world. And basically, a simple analogy could be, let's say that you are, at the grocery store, right? And there's only one cashier, and there's all these people who are ready to check out, right? And so, and that's the queue to actually pass data in and out of that environment, right? And we want to make sure that we set the right amount of cashiers, right? If you set 4 cashiers, you're going to be able to process four times faster, right? So think of that as more of the queue depth analogy. And also, when you talk about, a 1-lane highway versus a 4-lane highway, right? And since this talk is about taking the defaults, right? The default SCSI adapter is what we call the LSI logic adapter, right? By default, it's set to 32 for queue depth. We definitely want to change that to be what we call the para-virtualized SCSI adapter. And the default for that, for the queue depth, is 64, right? In addition to that, right, for maximum performance, we want to set that to 254, right? And so just by changing the default from LSI to para-virtualized SCSI adapter, we're getting double the amount of capabilities, right? And then also from changing that to 254, we're going to get exponential. And at the same time, a default VM only gets 1 LSI adapter, right? The maximum number of para-virtualized SCSI adapter per VM is 4. So for heavy workload environments, right, we want to make sure that we have 4 adapters for the VM. Okay, and so the screen that we're looking at here shows you how to do and allocate a para-virtualized SCSI adapter. Right? And I'll end it with this last statement, is that from a queue perspective, right, we set queue depth at the OS level, we set queue depth at the virtualized SCSI adapter, we set queue depth at the HBA level, and also at the storage LUN level. And for the HBA and storage, we definitely want to consult with our vendor on what that correct setting should be, right? And from a maximum performance perspective, right, we also want to make sure that there's multi-pathing device drivers on all of our SQL Server environments, and that also that from a write policy that we have a round-robin write policy across HBAs. So, and we also want to make sure that we tweak our settings and never take the defaults for a lot of these things. I think that's all I had, Kevin.
All right, that is fantastic information. We're going to have you back, Charles, and dig a little bit deeper into some of this, and maybe you can give us some live demos and show us this as it plays out. Everyone, thanks so much for your time. We know that you have a busy day. You've got a lot to get done, so we really appreciate that you have chosen to spend that time with us. We will be sending out an email to everyone who's registered that will have links to the slides, to the scripts, and to a video as well. So you'll definitely be able to see this and do more research as well. Also, while Charles was talking, I was answering some questions. Any questions that I didn't get answered, we'll come back with in a blog post as well to make sure that everyone gets their questions answered. So don't worry about that. We will cover that. Also, you know, as we have chatted about the possibility of us doing more sessions on this topic, you know, let me know and Charles know if there are any things that, you know, you'd like us to go into more detail on. You know, I saw questions asking about different storage subsystems. For example, pure storage, I have some experience with that. Charles has a lot of experience with these high-end systems as well. So if this is the kind of thing that we can help you with, we would love to get your requests and get a feel for where you are with your skills and what would help make this all better for you as well. So on behalf of Charles and his team, they're at viscosityna.com, viscositynorthamerica.com, and I am K. Klein at century1.com. Please come to our next session. If you liked this one, tell your friends. Promote us on social media in the future. Follow us on Facebook, LinkedIn, Twitter, that sort of thing, and hope you get some value out of it. If you're not using Plan Explorer, please take some time and download that. As I mentioned, we don't even ask for an email address, so there's no reason not to have this in your toolbox. You have just another moment or two to get in another question just before we wrap up. But with that, I would like to say thank you and hope to see you in the next webinar.
Thanks, everybody.